Please subscribe, like and watch. Thank you.
Welcome back. Problem 7.93. This problem is very interesting problem and is different from the previous problem. Clear? So pay attention to this as well. So let's start with the given data. So given data is taken from this state of stress. So you can see sigma x is equal to 8 ksi. Clear? Sigma y, which is not available, that is equal to 0, and tau of xy is again, that is tau of xy here is given as tau naught. Clear? Again sigma ut, I will write it, sigma ut is 10 ksi and sigma uc is 25 ksi. So what we have to find is, we have to check, we will apply Mohr criteria to determine the shearing stress tau naught. We have to find tau naught for which failure should be expected. Failure should be expected, but by using Mohr criteria. Mohr's criteria. So let's solve this problem. So again, you know that for solving this problem using Mohr criteria, we will need principal stresses, that is sigma A and sigma B. So sigma A is sigma average plus R and sigma B is sigma average minus R. Clear? So sigma average, we will find it, that is sigma x plus sigma y divided by 2. So that is 8 plus 0 divided by 2, which is equal to 4. So sigma average is equal to 4 ksi. Now R is equal to, you have already memorized it, sigma x minus sigma y divided by 2 whole square plus tau xy whole square. So put the value of sigma x is 8 minus 0 divided by 2, which is equal to 4 square, and tau of xy is given as tau naught, which we want to find. So tau square is equal to r. So again, if you want to find tau naught, that is equal to under the root. So this tau naught will be equal to r square minus 4 square under the root, and there will be a plus minus sign. Clear? So this is tau naught. Now you can put the value over here. So sigma average is equal to 4 plus r, and that is equal to 4 minus r. Clear? And this is 4 plus r ksi. Clear? And this is 4 minus r ksi. Again, you can see that this sigma average, the mod of sigma average, if you take the value, you can see this is less than r. How? Because you can see that sigma average is equal to r, and this value r is equal to 4 square plus t naught square, means it is greater than sigma average. Clear? And sigma average is less than r. So if you put the smallest value and add it, it will be positive number. So again, if this is negative, the smallest value, and this r is greater, clear? So this value will be, this will be positive and this will be negative, and again it will lie in the fourth quadrant. So we will apply stress point sigma A comma sigma B lies in fourth quadrant. Clear? So therefore the equation of fourth quadrant is, that is sigma A or sigma ut minus sigma B over sigma uc should be equal to 1. Clear? So 1 means that it will expected, or it will be safe, or it will be expected. Clear? So you can put the value sigma A is 4 plus R divided by sigma UT is 10 minus 4 minus R divided by 30 is equal to, sorry, 30 or 25. Let me check. This is 25. Sigma UC is 25. So 25, that is equal to 1. So again, if you take the LCM and solve it, you will get 1 over 10 plus 1 over 25 into R is equal into R is equal to 1 minus 4 by 10 plus 4 over 25. So when you solve it, you will get the value of R, and R will be equal to 5.429 KSI. Clear? Now you have this R value, you can put it over here. So T naught will be equal to plus minus 5.4929 square plus 4 square. So you will get T naught is equal to plus minus 3.67 KSI. So this is the value of shear stress for which the failure is to be expected. Again, if you want to solve, if you want to put it in envelope, you can also put. So for that you have sigma average plus R. You can have R value, you can get sigma A and sigma B, and then you have to plot sigma like this envelope. I have not drawn as per standard, but you will get the envelope like this, and then you plot sigma A and B to check whether rupture will occur or not. Clear? So if the point lies inside the envelope, it will be safe, but again it will be on the boundary edge of this line, or boundary edge of this line, so you can say that failure is expected. Clear? So I hope you have learned this problem as well. Thank you for watching.